All right, now that we've implemented our iOS, or rather OIS, object-oriented input system, established our input manager and keyboard and mouse setup, we also went ahead, if you remember, in the frame started, we looked for escape key, and if the escape key was pressed, we exited out of our scene. And the translate node was actually the thing that happened at the beginning of the frame. I moved this to the end of frame started, and then I'll include my game logic, my input logic above it, so that I would update my translation movement. And also we made the vector3 speed to be vector3 of 10, 0, 0. So that translated our object to the right. So let's make the speed to be 0, 0, 0 at the initialization. And here, when we run this code and it compiles and runs, then we should see that the Ogre now, or the Sinbad node, to stay in the middle and not move at all. And then we're going to go and implement our movement within the code. Okay, so as you see now, the object is in the middle, and when we press escape, we can exit out of the code. So now I'm going to implement my game logic for movement of the character. So the first thing that I'm going to do is, right after I checked and saw whether my escape key was pressed, I would return out of the game loop. And if the escape key was not pressed, then I'm going to go ahead and start implementing my logic. And here's what I want to do. What I do want to do is, when I have a key pressed, I want to add the amount of this, or rather a certain kind of amount, to my speed of the object at a given location. So let's take a look and see how it looks. So my node is basically at the middle of the scene, and this is the 3D view that I have. So, and I'm using a speed vector that basically tells me along the x, y, and z axes. So along the x, y, and z axis, how much I want the object to move. So the speed is going to be this red vector that I have. So I initialize it at 0. Then each frame, when each frame renders, I set the speed to be 0. So at the start of the frame, the speed will be 0. Then I would look to see which one of these keys are pressed. W, A, S, D. So if W is pressed, I'll put a, sorry, actually, my values are not correct. So X is the one to the right, and then Z is the one that's outside. So so then if W is pressed, then I make the vector to be -10, 0, and 0. If S is pressed, then I'll make it to be, 0, 0, -10 for W. When S is pressed, it will be 0, 0, and 10. When D is pressed, it would be 10, 0, and 0. And then when A is pressed, it would be -10, 0, and 0. Right? So what I'm going to do is, at each frame that is being rendered, so each frame is being rendered, set the speed at 0. Then look and see which one of the keys was pressed. And then, depending on which key is pressed, add their appropriate amount to the speed vector. And that updates your frame. So we go to the next frame, you set the speed at 0, you go through and see which key is pressed, you update, and so on and so forth. So let's go back to our code. So we're going to do speed equal vector3, 0, 0, 0. So at any given frame, we'll set the speed at 0 whenever the frame is being rendered. Then we'll check and see if our M keyboard is key down for each of these keys, K, C, A, or rather W W, S, A, and D. So if the W was pressed, then add to the speed the amount of vector 3, 0, 0, 10. That's if the S was pressed, if the W was pressed. Actually, all of these should have the OIS name resolution behind them. Okay, and if S was pressed, then do -10. If A was pressed, then do -10 on the x-axis. And if D was pressed, then do +10 on the x-axis. And once you set your speed, then you would go ahead and translate your node with that amount. So let's run this code and let's see how it looks like. W, S, A, and D. Obviously, as you see, my W and S are swapped. Let's take a look and see what happened here. So I said for the W, I want to move against the z-axis, so -10. For the S, I want to move towards the z-axis, so the z would be 10. And I think that my signs are not correct. So if W is pressed, you put -10. If S is pressed, you put +10. So, okay, W moved the ogre to the back. S, move it towards us. A, move it to the left. And D moves it to the right. Now, one of the nice things about this way of this code is that you can actually have multiple keys pressed. So, for example, if you do W and D at the same time, your ogre goes diagonally. S and A makes it move diagonally. So, and the reason for that is, see, I'm not putting these if-else statements as mutually exclusive. So I go and see if W is pressed, then I subtract 10 from the speed on the z-axis. If S is pressed, I add 10. If A is pressed, I subtract -10 from the x-axis, and D adds 10 to the x-axis. So as you see here, then what's happening here is that, you know, if you press W and A, then your vector is going to be -10, 0, -10, and then you move your object accordingly. So this is a simple movement that we have set up for our ogre to move it about in the scene. Now next, what I'm going to do is I'm going to go in and start working with your mouse input and getting control of the camera so we can rotate our camera around. All right, now that we have our object movement set up, we need to be able to work with the camera. So we need to do a couple of things. First, just like we set up a node pointer up here, we are going to go and create a camera pointer, and let's call it cam. This would be the pointer to the camera that we will pass to our frame listener from the original code. Then what we're going to do in the constructor of the frame listener, we're going to pass a camera pointer and call it camera. And then, just like what we did with the node, we're going to set these two references together. So when the frame listener is being constructed, we're going to pass to it a pointer to a node, a pointer to the render window, which we can use to register our input-output, and a pointer to the camera, which we use to be able to move it around. Since we changed the signature of our constructor, we will have to go to our base application also, and in the create frame listener, where we create our frame listener, we will also have to pass to it the camera pointer, which will be the camera pointer of the original application. So when we create our frame listener and register it to our application, we're passing to it a SynBat node, we're passing to it the M window, and we're passing to it the M camera. So with the SynBat node, we'll use WASD to move the SynBat. With the M window, we use to register our content, basically, or rather our input-output systems. And then with the camera, we use it as the underscore cam in locally in our frame listener to be able to control the camera, just like we did with the node. Now, one of the things that I've already done is I've already set up my mouse input. So that has already been set up. So we'll go to the frame started function, and we will start reading our M mouse with its capture method. So that registers the capture method of my my camera. Now, what I would want to do is I would want to get the X and the Y rotational movement of my my mouse, and then use this to be able to use the yaw or pitch of my camera to move it around. So what I'm going to do, so let's see how it actually looks like. So this is my camera, my scene. And let's hypothetically say that the camera is kind of pointing, it's pointing that way. So it has a X, Y, and Z axis on its own. That would kind of look like this. So what I would want to do is, and so the camera is looking, so that's what I see. And then I would want to see my mouse movement. So if this is my mouse, and when I'm moving the mouse on the x-axis, so when the x-axis of the mouse is being moved to the left and right, or the y-axis of the mouse is being controlled up and down, I would like to control the location or the orientation of my camera. So how does that work? What I would do is I would get the relative state of my mouse, and that would be through the mouse get mouse state .x .rel. So what that means is that every time the frame starts, I would look at the x of my mouse and see relative to the last x that I read, how much it has moved to the left or to the right. And for the y axis, I can also use the y.rel of my get mouse state to see how much up and down it moved. Then what I will do is I will use this x relative and the y relative values as the rotation amounts for yaw and pitch. So so if you remember, yaw was rotating around the y-axis, kind of. So if you have a vertical axis going upwards, the yaw will rotate your object, which in our case is going to be the camera. It's going to move the camera this way and that way. So this is going to be its yaw. And then the pitch is going to be along the x-axis. So yaw is there, and then the pitch is along the x-axis. So if you're using the y relative, then you would be able to pitch your camera up and down. So we're going to use these to implement our functionality. So so how are we going to do this? We are going to create a float variable, and we call it rotation x. And this rotation X will read from mMouse get mouse state dot X dot relative. So we get the relative amount of our X rotation, and then we're going to multiply that by event dot time since last frame, and then we're going to multiply that by -1, because in our case X and Y that we are reading from our operating system are going to be sort of flipped with respect to the amounts that you get from the Ogre. So that would be the relative rotation X. And we do the same thing for rotation Y, which will be the exact same thing, except that we would read its Y relative. Now that we have these two rotations X and rotation Y created, we're going to use the reference to the camera, or rather the camera pointer that we have, and then use yaw to rotate along the y-axis to move our view horizontally. And from this, we will use radian rotation X. And then we use the same concept for rotation Y, but this time we use it as pitch. So now when we run the application and we move the mouse upwards, then the camera tilts down, moving backwards. On the mouse, tilts the camera upwards. Then moving the camera on the x-axis to the right, moves the camera view to the right, and moving it to the back, to the left, should move the camera view to the left. So let's compile and run our application. So as you see with the WASD, I can still move my Ogre left and right. And now with the mouse, if I move the mouse to the left and right, it rotates the camera to the left and right. And then moving the mouse up and down would rotate the camera up and down. Now I can't move my camera actually with WASD anymore, because I'm using WASD to move my Ogre. So one of the things that would be nice to do is to create a third-person camera. So I want the camera to be placed behind the Ogre, or my node, and then to be able to use my camera views to pan and tilt. We will do that in the next couple of minutes. All right, so it's really nice. We can now move the camera by rotating it up and down and left and right. And then with WASD, we can also move the Sinbad node, or character, left and right and up and back and forth. However, the two are disconnected. So my camera is sitting somewhere in the world, and then I can move it around, but or rather rotate it around, but I can't pan it. And then also the character is kind of moving independent of the camera. So what I want to do now is to make the camera to be a third-person camera. So for a third-person camera, that I'm gonna set up now. This is my character, and right now, so if this was X, Z, Y, and X, and so the camera is kind of sitting there independently, and which is right now. So in the third-person camera, what I want the camera to be, the TP camera, to be kind of connected to my object, so that when the object moves, the camera moves with it. So the idea then is to create another scene node here, and then child this scene node to the scene node of my character. So this is Sinbad node. And what I'm going to create here is a camera node. And then I'm going to make the camera nodes to be the child of Sinbad. And then I'm going to make the camera to look at the 0, 0 location where my object is. And when I do this, and then I attach the camera to it, and when I do this, then I can still rotate and pan my camera by moving the mouse up and down and left and right. And with WASD, I can move my character back and forth and left and right. And then the camera will move with it. So let's actually try to do that. So the idea is then, one, create a scene node. 2, make it the child of Sinbad, and then 3, attach camera to it, and 4, make the camera look at 0, 0, 0, and that way we'll have our camera set up in a third-person view. So let's go ahead and code and do this. So we will do all of this not in the frame listener, but in actually our base application and my interactive example application. So in the create scene, remember we had a camera that we had a create camera position here. So create void create camera, which is m camera, and we called it camera 01. So now my m camera has been created. Then what we did is we set the position of the camera, the lookout of the camera, and the clip distance of the camera. So let's move these actually down towards the end of our application. So now what I'm going to do is I'm going to create a scene node pointer, and I call it cam node. And I'm going to make this to be the child of Sinbad node. Sinbad node, create child scene node, and I'm going to call this cam, or rather TP camera 01. This will create my, or rather, let's call this TP camera, TP cam underscore node. Then what I'm going to do is I'm going to attach my m camera to it. So it's going to be cam node, attach object m camera. So at this point, actually, let's run this one at a time. Let's also comment out these sections that we moved down, so we'll see exactly what happens with our scene. So let's compile and run. So what I created is I created a scene node that's the child of the Sinbad node, and then I attach my camera to that scene node. Now the view that we have, it should be from the pivot of the Sinbad node viewing out. Okay, this makes sense. So now we won't see anything is because the camera is now kind of inside of the Sinbad, which is one of the problems we have. So one of the things that we need to do is we need to fix this problem. So remember, Sinbad is sitting at the center of the scene, and it's pointing towards us. So let's now translate the cam node. Let's translate it at, let's say, 10 units upward on the y-axis with respect to the Sinbad, and then 20 units on the z-axis. So this moves the camera out of the screen. Okay, so this is good because now we move the camera out of the screen, and as you see, we can kind of sort of see the Sinbad. And the problem is right now, when the camera moves, it kind of clips the Sinbad out. This is actually an interesting problem. However, we can move now the Sinbad, and as you see, the camera moves with it. So one of the problems that right now we actually do have is that the clipping is not set properly. So we're going to uncomment the clip distance to 5 units. Right now it's kind of like 20-30 units, and that's what causes the clipping to happen, and half of the Sinbad is going to get cut out because it's too close to the camera. So we change the clip distance. Now you see we're not clipping the Sinbad anymore, but the original view is kind of upwards. So we're going to make the camera to also look at 0, or rather look at the origin. And now we are in a very nice third-person view. And now we can move the camera around, and we can also move the Sinbad left and right. However, the camera is not really a good third person because it's now in front of the Sinbad. We want it to be behind the Sinbad. That's actually a nice problem, and we can fix it very easily. Remember, we put 20 in the x-axis, so we got to do -20. 20 in the z-axis, so all what we need to do is to move it -20. That moves the camera behind the Sinbad. I also got rid of the commented version of camera translation, or rather camera set position, because I don't want the set position of the camera to be global. I want the camera to be in the node and then translate the node with it. And now the camera is behind the Sinbad, which is nice. And as you can see, you can move left and right, up and down. And then now, since the camera is behind my object and it's kind of flipped 180 degrees, now all my angles or all my translations are flipped. So with W, I go back. The character goes back. With S, the character moves forward. With D, the characters move left. And with A, the character moves to the right, which is kind of everything is flipped. It's because the camera is now behind the character, and we had the camera to kind of totally rotate 180 degrees. I'm going to fix this problem by doing two things. One is that since here I set the speed vector at 0, and then I'm adding the speed to the vector as -10, 10, and then -10 and 10 on the x and the z axes, it's basically creating or rather modifying 4 vectors. So what I'm going to do is I'm going to rename the speed to the direction. So we're going to go and say direction instead of speed. And then we're going to set the direction at 0, and then direction, 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 and direction. Then since I'm flipping, so all of my directions are flipped, I'm going to change -10 to 1, and then -1, and then 1 and -1. So now what I'm doing is I'm actually making a direction 1 for when you press the W, so the character moves out or forward, then -1 for S, then it moves backwards, and then for A, I move to the left, and then for D, I move to the right. So those are my directions. Then I'm going to also create a float variable, and this time I'm going to call this to be the speed, and then I'm going to make this to be 10.0f. So, and when I'm translating, then I'm going to translate speed times direction times event since last frame. So now I have a float variable that controls my speed, so I can change it to whatever value I want. I have a direction vector that could be any number of these directions. So if you're pressing W, it's going to be 0, 0, 1. So the character moves outwards from the scene on the z-axis. And for the S, it goes inwards to the C, so a negative z-axis. And then for A, it goes to the right, which is positive x-axis. And for D, it goes to the left, which is negative z-axis. So I use -1, 1, 1, and -1 for my directions. And then I can simply multiply my direction that I created and times the speed that I have, and that way we will set the directional movements. So now let's try this and see how it works. Okay, so this is our scene. So mouse left and right moves the camera, mouse up and down moves the camera, and then with W you go outwards, you go forward. With S the character goes backwards. With D the characters move to the right, and with A the character moves to the left. One of the things that again we have to notice is that since the character is actually looking towards the positive Z-axis, after I move the camera behind the character and had it rotate to look at the 0, 0, 0, that's when my all my axes were flipped, so I had to correct that. Okay, so now that we have our camera in third-person view and set up quite nicely, I'd like to talk a little bit about how we can actually utilize the speed that we have created with our input values to be able to speed up or slow down our character as well. And as a part of talking about this and implementing this speeding up and slowing down process, I would like to also talk about timers in Ogre and show you how you can use these timers as sort of gates, in that when you're pressing the keys, especially if you have a fast computer, while the key is held down, several frames may happen. So while we think that we are using one of those keys as being read, since our response time is much slower than the number of frames that are being processed by our computer, in fact, when the key is held down, by the time we press the key and release the key, several frames have been processed, and at the start of each of those frames, the speed up has been evaluated, has been recorded, or rather, these key read has been recorded. So I want to magnify this and show it to you. So one of the things that we did is I created the float variable here in my frame started. So I moved this float variable for my speed, which is 10.0. And I'm using this as a global variable for my class in the private variables. So I have a float speed 10, which then I'm going to use actually in the frame started mode to multiply by the direction, so speed times direction. That calculates the amount of displacement for my character. So let's think about holding left and right shifts to speed up and to slow down. So left shift. Let's say that we want this to slow down our character, and then right shift, we want it to speed up our character. So I'm going to use my M keyboard is key down, and I'll see if it is OIS KC_L shift. And if that's the case, then I'm going to slow the character down. And the way that I'm slowing my character down is I'm going to subtract 5 units from it. So I'm going to go if, let's do speed -5. So this is going to subtract 5 units from the speed. And I want to make sure that speed is going to be positive. So if the speed becomes negative, then speed equals 0, and then set it as 0. So left shift basically slows my character down. I'm going to do the same concept for my right shift, and instead I'm going to speed my character up. So if is key down is R shift, then add 5 to the speed, and this time we'll check to see if the speed is greater than 100, then we make it 100. Okay, so what we are doing is if we press the left shift, we slow down our character. If we press the right shift, then we speed up the character. So let's see what happens when we do this. Okay, so with the right shift, when I'm pressing it, see, it just speeds up my character. And then with the left shift, it automatically slows it down. With the right shift, it speeds it up. And then with the left shift, it automatically slows it down. However, there's a slight problem. I don't know if you notice it, but let's try it. So I'm pressing the W, and now I press the right shift. My character really speeds up really fast. And then it maximizes at 100. Let's not cut the speed at 100. Let's cut the speed at 1000. So this time, I'm only adding 5 units to my speed every time the shift is pressed. But the problem that I will get, and you will notice it now, is that the speed up seems to be much faster than just adding 5 units. Okay, so now I'm moving forward, and all of a sudden, this is really going fast. And then the moment I press the left shift, it automatically, quite immediately, looks like it's slowing my character down. So what is going on? See, I just pressed the right shift, and it's just sped up really fast. And then I just pressed the left shift it didn't even take a few milliseconds, even a second for me to press the left shift, and I'm slowing down really quickly. Now, this is the problem. Let's go to the board and check it out. So the problem that I have is that my character is here and is moving upwards, and then I press the right shift. Now, while I'm holding the right shift down, several frames will occur. And although I'm just pressing the shift really fast, by the time I release it, since my reaction times are small, I may read, I don't know, maybe 20 frames. By the time I press the shift, I press it down and release it, 20 frames may have passed. And when this actually happens, then effectively, by the time that I press the key and I release the key, and that there were 20 frames that happened, the speed basically got added up by 5, but times 20. So effectively, it added 100 to the speed just by a simple, quick press of the shift down and up. And so that is the problem that is caused here. That is, when we are using raw inputs, basically, so effectively, when I'm looking at the key being pressed down and just directly subtracting or directly adding some units to my speed, this might happen. Even a quick press of the shift might happen 20 times, might happen 30 times, because this is on frame started. So every time the frame started, this subtraction or the addition to the speed happens if the left shift is pressed. So while the left shift is pressed, if multiple frames started happen, then multiple times the speed will be added. Now, this simple solution to this is to use timers. Timers basically are a means in Ogre that you could create a variable, and then these variables will start counting from the moment that you reset them. So what we'll do is we'll add a timer in our frame listener, and then we'll reset it in its constructor. So once the frame listener is constructed, its timer starts ticking. And then we can look at the timer at any given time and see how many seconds, how many milliseconds, or how many microseconds have passed. And we can use this number in our logic to be able to do our subtraction of speed and addition of speed, not only on the left shift, but also on how much time has it been passed since the last time that we did this subtraction and addition. Let's see what happens, how we can do this. So first, we're going to go to our frame listener, and we're going to create a timer variable and call it timer. And so this is going to be this will create a timer for me in my frame listener. Then I'm going to go to the constructor of my frame listener, which is up here, and then I'm going to reset this timer. So underscore timer reset. This will basically reset the timer and let it go start from 0 and then keep going. This will keep running in terms of milliseconds and how many milliseconds have passed. Then what I'm going to do is I'm going to go and see if the left shift has been pressed. And if it has, if the timer dot get milliseconds or get milliseconds is greater than, let's say, 200. If that were the case, then we are going to add to the speed and then reset the timer. Okay, we're going to use the same logic for our right shift as well. That was speed up, and then reset the timer. So let's go over this and let's see what happens. So now I have a timer created for me. So this is my timer in the class declaration, and then I reset it when my constructor is created. The moment that my frame listener construction creates, the timer starts ticking. So basically, it just counts on milliseconds, and it keeps the time. Then in my frame started function, what I'm doing is that I'm checking to see, actually this must be reset. So what I'm checking is, I check to see if the left shift has been pressed. So the moment, let's say one frame starts, and I look and a left shift has been pressed, I'm going to go into this if statement here. And then I'm going to look at the timer and see, hey, since the last time that you were reset, has 200 milliseconds passed? Have 200 milliseconds passed? If yes, then subtract the speed, and also make sure that the speed doesn't go negative, and then reset the timer. Now, if the next frame started happens, and I'm still holding the shift key, since the time will not probably be 200 milliseconds, then the second press of the shift in the next frame and in the next frame and in the next frame are going to be ignored until the shift has been kept down until 200 milliseconds later than the last time that the shift has happened or the subtraction has happened. I'll do the same thing with my my right shift to speed up. So I basically, effectively, what I'm saying is that, hey, is the right shift down? Yes. If it is down, when was the last time that the timer got reset? If it is long enough since the last time it got reset, then add to the timer, to the speed, and then reset the timer. So the next frame that comes in, if the right shift has been pressed, is still pressed, but it's not 200 milliseconds later than the last time that I added, I'm just gonna ignore this adding of my speed. So let's compile this and let's see how it works. So now basically, I should still speed up my character, but now the speed up will not be really too fast and too quick. So effectively, with like 200 milliseconds, I can take into account my response time. So if I press once and release it, it's going to only hopefully just be added as one time. So now this is my character and it's moving. So I'm pressing the shift, and as you see, the shift slowly adds up, and then the right shift slowly slows me down to a stop. I'm moving backwards, speeding up, and as you see, my speeding up and slowing down are now much more reasonable. So let's see. Now my speed is 0, so if I press once, now that's 5, 10, 15, 20, 30, 40, 50, and so on. So every time I press the key, if I want to continuously add to my speed, I would have to hold the key down so that multiple times the addition or the subtraction of my speed occur. So basically this 200 milliseconds that I'm using, it basically is taking into account as in that if multiple frames are rendered within the 200 millisecond time frame, only once in this time frame the summation or the subtraction of the speed will occur. So this is a quick quick overview, or rather a good overview of how you can set up your input-output system with Ogre and the object-oriented input system mechanism. We saw how we can use this input-output system to register mouse event and keyboard events, and then we also learned a little bit about timers in Ogre and use a timer as a kind of a gate to not read consecutive readings of a key press over multiple frames, but rather kind of hold within a time frame and use a more of a discrete way of reading key inputs and so forth. So hopefully this was a relatively nice review, or rather study of interactive applications in Ogre with using your mouse and keyboard and frame listeners. So this is going to be the end of this lecture video with effectively the contents of your Unit 7. And in the next unit, we will get a little bit deep into animation with Ogre 3D, and we'll learn how we can actually then animate this object, the Sinbad, and other objects in our Ogre. And that should, the next video lecture, wrap up our journey with the Ogre. So I hope that you enjoyed this video, and please go ahead and implement the work and go over and study the reading materials from your textbooks and online. And I will talk to you in the next lecture unit, which will cover animation in Ogre.